Good morning, everybody. My name is Ulrich. Today, I'll be talking about the interference and diffraction of light. Uh, my group is a four-member group with Usman, Sarah, and Jason. The first part will be about the interference of light. The second part will be about the diffraction of the light, and then the third part will be about the real application of live example for the interference and diffraction of the light. First, when we talk about interference of light, what is interference of light? Interference is the process in which two or more waves of the same frequencies, be it light, sound, or other electromagnetic wave, either reinforce and cancel each other. The amplitude of the resulting wave being equals to the sum of the amplitude of the combining waves. What does it mean? You may have noticed when a film of a floating foil in a puddle reflects light, a swirling mass of rainbow colors seems to magically appear. The cause of this phenomenon is the interference between light waves. A subbubble floating in the airflow also reflects a variety of beautiful different colors. Waves don't normally reflect when they strike one another, instead they combine. If the amplitude of two waves have the same sign, either both positive or both negative, they will add together to form a wave with a larger amplitude. For example, if at a given instant in time and location along the medium, the crest of one wave meet the crest of a second wave, they will interfere in such a manner as to produce a supercrest. Similarly, the interference of a truth and a truth interference constructively to produce a super truth. This is called constructive interference. If the two amplitudes have opposite sign, they will subtract to form a combined wave with a lower amplitude. For example, the interaction of a crest with a truth is an example of destructive interferences. Destructive interference has the tendency to decrease the resulting amount of displacement of the medium. If light is passed through two slits closer together, the wave will interact and the diffracted beam can be seen on the screen to have bright or dark band on it. The bright band show constructive interference of light. The dark band show destructive interference. As we look, we can look at the Young double slit experiment. Light propagation direction. Light propagation direction goes under the intensity distribution of frames, which create destructive interference between the barrier of the double slit and the constructive interferences on the screen, coming from the screen. Those are just molecular expressions of the light. Young interference experiment, also known as the double slit interference interferometer, was the original version of the modern double slit experiment performed at the beginning of the 19th century by Thomas Young, a British scientist who is well known for his experiment. This experiment played a major role in the general acceptance of the wave theory nowadays. What's the condition for interference? The two sources of light should emit continuous waves of same wavelength and same time period, so that the sources should have a same phase coherence. The two sources of light should be very close to each other so that they can combine and cancel out. The wave emitted by two sources should either have zero phase difference or no phase difference. What is coherent sources? Those sources of light which emit light wave continuously in same wavelength and time period. Frequencies and amplitude have zero phase difference or constant phase difference are current sources. Types of interference. There are two types of interference: constructive and destructive interference. As a reminder. Thank you.
So my topic of discussion is diffraction of light, and diffraction is basically when light waves encounter some sort of an opaque object or obstacle or a slit and sort of bends its way through the obstacle. In order for diffraction to take place, we must have an opaque object. If it's translucent, the light waves will go through it or reflect off of it, which is completely a different topic. It would either be reflection or refraction and not diffraction. Diffraction is when the light waves are bending and not going through the object or reflecting off of it. If you look at slide 5 of our presentation, you can get a better visual representation of what really happens to the waves as diffraction takes place. The best example of diffraction I could give is probably if we're in a classroom and the lights are turned off and the door is slightly open, leaving this amount of a gap. And if the lights of the hallways are turned on, we can still see the light that's in the hallway, even if we're not in the hallway, we're in the classroom. So that just shows that light is making its way into the classroom by bending through that little gap of the door, which then makes the waves visible to us. So once the light leaves the light source, for example, a lamp or a flashlight or beam of any sort, it is a plane wave, meaning that it's coming in a uniform pattern, kind of like magnetic field. They all go in the same direction at the same time. They can encounter objects, like I said before, or they can encounter slits. Usually when they go through slits, it's easier to observe what happens during the interference of the light waves with each other and with the object itself, or the slit itself in this case. During a basic slit experiment, we can observe that the uniform waves are coming in from one side, and as soon as it hits the slit, it comes out the other side as a spherical wave. Kind of like the ripple effect. When you throw a rock in the water, you can see the rings that form, and it's like a ripple. So when the lights go through a slit, it's like half of the ripple on the other side of the slit. So depending on the number of slits on a barrier, um, it will affect the diffraction pattern a different way. For example, if there is one slit, the outcome will be different from if there's two slits, because if there's two slits, the waves are going to overlap. They end up sort of like canceling each other out, so the outcome and the diffraction pattern of light on the other side of the two slits will be different from what it was like if there was only one slit. So the interference that these slits are causing can either be constructive or destructive. Constructive means when the waves are in phase with each other, and destructive means when they're out of phase with each other. Constructive is when the amplitude and the frequency of the waves are the same, so they're completely in phase with each other. The other interference is called destructive. That's when the waves are completely out of phase. This is what happens when they go through slits. They usually have some sort of difference in the wave paths, and they go in their own direction and they have their own thing going on, and they're completely out of phase, completely opposite to constructive interference. So there's a guy called Huygens Fresnel. I'm sorry if I said his name wrong. So this guy basically said that light does bend, and we can see from different experiments that light will go from point A to point B no matter what. So this relationship can actually be represented with a basic kinematic equation, x equals vt, which basically, relates the velocity over time that the light waves go through in order to reach point B from wherever they started. So since his principle does deal with, lights traveling at a certain speed over a period of time, his idea doesn't only relate to diffraction, it also relates to refraction, to reflection, and other interferences of light.
Everyone. Today I'm going to talk about a real-life application. Example for interface of light. The most common one is the soap bubbles. The thin films of a soap bubble will reflect a spectrum of beautiful colors when illustrated by natural or artificial light source. See those marvelous colors amongst the visible spectrums of EV waves. Only a few are visible while others are not. The reason being that phase of the electromagnetic wave change during refraction and refraction. As light travels through millions of different refraction instances, the images waves then interface with each other, some constructed and some destructive to give those patterns to on bubbles. As you can see, two waves that are similar to each other will combine to be a larger size of wave, and two waves with opposite size will cancel each other out. Why does light form two light bubbles, no form interface patterns? The light source are a source of light waves that have regular phase of difference between them over significant duration of time. Two waves might have the same frequency and wavelength but be offset from each other in, in that they are different points in the complete cycles. For instance, one wave could be a crest position just prior to the moments in time when other sources are creating a crest. They are said to be out of phase. Yet, if they mean the same directions of phase, they are considered the cohesive light source, even if the source of light do not stay in step with each other, as long as the amount of which they are out of step remain at the same over time. The light sources are said to be cohesive. Two waves must be the same frequency and there must not be any disruption of their cycle over the course of time. Example for diffraction of time. X-ray serves and science purpose. This X-ray is different. When X-ray pass through crystal and undergo lattice diffraction, different crystals produce different diffraction patterns, which infers how the atoms that make up the crystal are arranged. See the pictures on the side. The one is from EFG, and then you can see from the point of the lasers, you can see how you can determine the shape of the holes based on how the lights perform. A hologram is no word delivered from the Greek holo, and gram messages. This is three-dimensional impress of an object, and the method to produce those images is known to have holograph. Holography makes use of laser beams that mix of angles, produce an interface patterns of alternating bright and dark line. The surface of the hologram itself is a sort of diffraction gratings, with alternating strip of clear and clear materials. By mix of laser beams and underforce focus diffraction patterns of an object, an image can be recorded and illustrated laser beam is diffract at specific angles. In accordance with Bragg's law, on the surface of the hologram, it made possible of the observers to see three-dimensional images. That's how it. That's how the future is going to with the diffraction lights. Thank you. Hi everyone, Usman here. So today I will be presenting about the interference and the diffraction of the light. So light travel in a medium straight as a straight line, and basically interferences and diffraction characterize the undulatory effect of the light. So what do I mean? So I just said that light travels as a wave in every medium, right? So here we can see that the light is bypassing this stick over here so that it can continue to travel. So that means that light only pass through a transparent medium and it is always going to avoid obstacles. Next, diffraction. Well, diffraction is the spreading of the light after the spread of the light after it goes through how can I say, a slit like here, a slit here. So here we have a white slit. We can see that we have a incoming source of light. So as soon as the light goes through the slit, it spread. And here the slit is narrower, so as soon as the light goes through the slit, it spread. So basically that is diffraction of the light. That is spreading of the light as soon as the light goes through a slit. Next, this is the principle of Fresnel, which explains how light can bend and spread to areas and how waves interact with each other. So basically, we have two type of interferences. One is called constructive interferences. If you have a source of light going through a slit and then a screen, we can notice different points where you can see constructive interferences and destructive interferences. When you have a constructive interference, that the light has the two waves of light are into a phase. Basically, that's the simplest way I can say it. So they have the same phase, meaning they have the same phase difference. So with that, that's why you are seeing dots, like bright dots on the screen when the light is diffracted from the slit. When you have destructive interferences, that means the two waves are out of phase. So there on the screen you are gonna see a spot where the light is not showing up. That's a destructive interference. So we do have live applications like X-rays, and yeah, like X-ray is a good way to explain interferences because they use that um in medicine to see through your body what's happening there. And basically that's it. Let's wrap it up. So interferences are the ondulatory aspect of the light, and we have two types of interferences, constructive and destructive. And if they are constructive, that means that they are in phase. If they are not, they are in different phases. That's why that's why um we have dark spots and bright spots when the light spread out of the screen. So this was my presentation on the interference and diffraction of light. I hope you will enjoy watching this as well, me embarrassing myself. So thank you for this opportunity to let me express my opinion and my knowledge about interferences and diffraction. Thank you.